Hi everybody, it's Professor Mitchell. I am redoing just the very beginning of this video. We had a little technical glitch when we were doing it in class. So what we're doing at this point is we're jumping back to Chapter P. We're going to do several sections from Chapter P to warm up for Section 5.1, which is verifying trigonometric identities. And you'll see in that section we're going to be using a lot of algebra tricks, and so we want to make sure that everybody's up on their algebra. So in this section, we're reviewing rules for dealing with exponents. Hopefully you'll find that just about everything we go over in here is familiar to you. We have the product rule, the quotient rule, rule for dealing with zero exponents, for dealing with negative exponents, and then several rules for dealing with powers of expressions, powers of other powers, and then powers of products and quotients. And at the very end, we'll throw some of these rules together. Okay, so first rule is the product rule. When you multiply powers of the same base, you add the exponents. Now it's working, now that I'm sharing the right screen. So the way I always like to explain this is if you have an x to the third times an x squared, I'm going to make these exponents nice and small. So just remember what that means. It means x times itself 3 times, and then over here x times itself 2 times. So in total, you're multiplying together 5 copies of x, right? So that rule makes a lot of sense when you stop to think about it, right? Okay, the next rule is called the quotient rule. So when I'm talking to especially a beginning algebra class about these rules, I'll say, okay, look at the last rule. The last rule said to multiply powers, you add exponents. So this rule is saying to divide powers, you subtract exponents. Okay. And again, you can put an example in here that'll help it make a lot of sense. If this was an x to the 5th, and on the bottom you had an x to the 2nd, there are 5 copies of x upstairs and 2 copies of x downstairs. So what's going to happen is that the 2 x's that are on the bottom are going to take away 2 of the x's that are on top, right? All right, so it's almost like the classic old elementary school word problem. If I give you 5 x's and I take away 2 x's, how many x's do you have left? You have 3, right? So you subtract the exponents. Okay, that kind of looks like a 3. All right, then we come to the zero exponent rule. The zero exponent rule is one that people sometimes struggle with because it seems kind of counterintuitive. So this is saying that as long as b is not 0, b to the power 0 will always be 1. A lot of people, especially when they first get into beginning algebra, think that b to the 0 should be 0. Okay. Well, there's a really good reason why b to the 0 should be 1. The reason I always give is, okay, on the one hand, let's say that you had, or not on the one hand, let's say that you had b to the 4th divided by b to the 4th. On the one hand, that's a number divided by itself, which should be 1. On the other hand, if the quotient rule works, the quotient rule from the last slide, that says that you should be able to subtract the exponents. And if I subtract those 2 exponents, I get 0. So as long as you buy both of those methods of doing the problem, it's telling me that b to the power 0 should be 1. The only place it falls apart is if b is 0, because then this thing is undefined. Okay. 0 to the 0 is actually something you talk about in calculus. It will always be undefined, all right? But it will be something that you talk about in calculus when you talk about limits. All right. Next rule is about negative exponents. I don't think this one's come up in here before. Negative exponent means reciprocal, all right? It always looks a little less frightening when you put actual numbers there. So for example, this is saying that 3 to the power negative 2 is the reciprocal of 3 to the 2. So 3 to the negative 2 would come out to 1/9. Okay. So after we've gotten through all these rules, there's a slide in here that talks about what does it mean for your expression to be completely simplified. One of the rules is that it should not have any negative exponents in it. So this rule tells you how to fix up negative exponents. Okay. All right. Next we have the power rule for a power to a power. All right, when you raise a power to a power, you multiply the exponents. So if you had x to the second here, and then that was to the power 3, that means 3 copies of x to the second. And so if you write it like that, then it just becomes your product rule, right? X to the second times x to the second times x to the second would be x to the 2 plus 2 plus 2, which is 6, right? So the shorter way to do that is just multiply the exponents, okay? All right, moving right along. We have the product to a power rule. So I've always thought of this as kind of a distributive property for exponents. I don't know if it's technically correct to call it that. When a product is raised to a power, you raise each factor to that power. So this one is especially fun when some of these factors already have exponents on them, and you'll see that in the examples. Okay. That works for products. And it also works for quotients. When a quotient is raised to a power, you can raise the top and the bottom to that power. Okay. Let's talk about what you're not allowed to do. Please, 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 please don't ever do this. There is no easy exponent rule about raising a plus b to a power. So a plus b to the power n is definitely not a to the n plus b to the n. Students who do that on a test get their test back with this written on it. Okay. And it doesn't work for a minus b to the n either. The only way this is a nice simple rule like this is when it's multiplication or division happening inside the parentheses. All right, so that's the end of the exponent rules. So now let's review what does it mean for an exponential expression to be simplified. When they ask you, you know, I hear students say this all the time, how do I know when I'm finished with the problem? All right. Well, if they're asking you to simplify an exponential expression, that means that the answer should not have any parentheses. It means that you shouldn't have any powers raised to powers. I'm not sure if we really need to say that, because if you had a power raised to a power, you would probably also have parentheses. I definitely need to say this, though. Each base occurs only once. So if your answer comes out to be a fraction, which it often will, you shouldn't have x to the 5th on top and x to the 3rd on the bottom, right? Because you have a rule for simplifying that. And then finally, you shouldn't have any negative or 0 exponents. You use the 0 exponent rule and the negative exponent rule to get rid of your 0 and negative exponents. All right, so let's look at a couple of examples, starting with a really, really easy one on a scale from 1 to 10. This is about a 1.2 right here. X to the 11th to the power 5th. So think about, is the answer x to the 16th, or is it something else? Hopefully you remembered that this is the power to a power rule. This is the one where you multiply the exponents. So this one comes out to x to the 55th. If you're wondering what problem does have the answer x to the 16th, that would be if it said x to the 11th times x to the 5th, right? That one would come out to x to the 16th. Okay. Next we have the third power of -6 over y. So I showed lots and lots of work for this one. This is the quotient to a power rule. So the first thing I did was I moved the negative sign up to be next to the 6. I just thought it was a little simpler to do it that way. Most people do this step without even really thinking about it. And then you use your quotient to a power rule, put the third power on the -6, put the third power on the y, so that gives you third power of 6 divided by third power of y. Notice I'm putting the whole entire -6 in parentheses. In this problem, it wouldn't matter if you did that or not, but in about half the time, it will matter, right? Because if this exponent was even, it would knock out that negative sign altogether, but only if you put it in parentheses, okay? So now I can either figure out or ask the calculator, what is -6 to the third power? It is -216. And you could leave your answer like this. It seems to be a little more common that people put the negative sign out front of the whole fraction. So that's how I would write that. All right, that brings us to this example up top here. I would have liked to have made these examples come up one at a time, but when I opened up this PowerPoint, this whole thing got saved as a picture, and so I couldn't pull these two problems apart. No big deal. Okay, so for the top one, here's how that looks. So you just divide, how would you say it? Well, you just divide 35 by -7. 35 divided by -7 is -5. And now I'm going to use my quotient rule. So when I do a to the 14th divided by a to the 7th, I subtract the exponents. When I do b to the 6th divided by b to the 3rd, I subtract the exponents. So in the end, this just comes out to -5, a to the 7th, b to the 3rd. And I can leave it just like that because both of those exponents are positive.